Hello, everybody. Thanks for coming to another version of the EMC podcast. And today I have Thomas Henshin here. Thomas, thanks for coming.
Thanks for having me.
And one of the things we're going to talk about is some new developments on EMC, especially about electric vehicle testing. So one of the things that you've been working on, Thomas, for the last
3 years.
3 years, yeah.
3 years, yeah.
So you've been working a lot closely with standards committees and car manufacturers and things like that.
Yeah.
So, I mean, you literally just packed the device this morning, right?
Yeah.
We're shipping the first one out. That's PowerWave.
Yes.
So tell me the story. Where did this come from? How did this come about? I mean, what's the problem we're trying to solve? What was the feedback from the community?
Okay. So actually, we got approached by car manufacturers and component manufacturers that they were in need for test equipment to test according to specific standards like the ISO 21498 or LV123, etc. And they just didn't have test equipment to perform the tests they wanted. And that's when we started to develop the new products.
Interesting. And what problem did they find in the vehicle that needed a whole new test design around it?
Yeah, the main thing is that compared to cars with combustion engines, that in the electric vehicle, the actual thing, the engine that drives the car is electrical now. So the high power device on the car is now electrical, which is a complete new world for the car manufacturers, for example. So, and this also causes like new problems, new challenges, and these things need to be tested.
What, for example?
So one thing is that, for example, when you're accelerating the car, the battery voltage drops quite significantly.
Mm-hmm.
And you need to reproduce these voltage variations. And that's where we have the PowerWave, the new power source, developed for it.
So one reason that we made the PowerWave is the different voltage curves and variations
exactly.
that happen in
that are defined in standards. It's pretty fast voltage changes, or like slow ones from 2 volts per second, but up to like the low dump pulse is 250 volts per millisecond. So very fast and steep changes in voltage.
Okay, and so the car manufacturers found these problems. They decided to write them into their own standards.
Exactly.
and so one is the case of these voltage curves. What's another use case? Another problem that we're solving?
Yeah, one of the biggest problems on electric cars is actually the ripple currents and voltages generated by the motor inverters. So the motor inverter is switched. It switches, so it generates some switching noise and switching currents, and this is ripple. And ripple is one of the most challenges, or biggest challenges in electric vehicles.
And the PowerWave does that on its own, or that's the reason for the ripple in it?
That's the reason for the other new product called Ripple NX.
Okay.
It's a high power ripple generator that does specifically generate this disturbance signal, this ripple signal, which is then superimposed on the DC supply lines. So the component, like the battery or the motor inverters, then you generate the ripple to basically disturb these components.
And the ripple comes from, in the real world, the ripple comes from what?
From the motor inverters.
From the inverter. Okay.
Yeah.
Okay. And so just one step back again. So that means that the PowerWave is used. Did I use the right word?
Yeah.
PowerWave. PowerWave is used in a couple of different situations. So until now, you've talked about inside the problems that happen inside the car.
Yeah.
But that's not all they can do, right?
No, that's not, because once the car is assembled together, you do what is called full vehicle EMC tests according ECR 10. That's the United Nations regulation. And since a couple of years, there's additional tests required for EVs during charging. And that's where also the PowerWave is used to basically power up the car or charge the car during this ECR10 tests.
Okay, so it acts as a charging station.
Yeah, it's the power part of the charging station, exactly. It needs another component, which is basically the simulation of the charging station, which is kind of like a protocol simulator, which we don't have on our own, but which is provided by a partner called Comensum in Germany. So the full solution is actually a power source plus a charging station simulator. Yeah.
Okay, so this necessary communication that comes back and forth from the charging station to the vehicle, that's also handled by kind of an integrated.
Yeah, exactly. It's an integrated system or solution, I call it. Yeah.
Okay, so from the charging station simulator, and what about when the charger needs to be tested? Do we do?
This is actually the opposite setup. So if a charging station needs to be tested according to the charging station standards, you need something that actually acts like a load, so like that replaces the electric vehicle during testing. So the power wave can be used on this side. So it's mode 3, so AC charging, or mode 4, DC charging. But also the charging station has a grid side, so the supply side, which can be replicated by a power wave as well. So single split or 3-phase clean signals, you can generate grid disturbances like superimpose harmonics or frequency voltage variation, things like that.
Okay, and do we also test simulations to the mains input to the charger? Not
exactly, yeah. So the power wave can actually be placed on both sides, on the input side of the charging station as well as on the load side.
So together with Ripple NX, we have a solution that simulates mains disturbances to the charger, simulates a charger itself, simulates a load for the charger, and simulates high voltage in a component test or a full vehicle test?
In a component test.
In a component test. So really it's 4 devices in one?
Yeah, the power source is really a very versatile source that can be used for many different applications. And in addition to these electric vehicle tests, it can also be used to simulate grids for solar inverter testing or wind turbine inverter testings. There's also DO160 mil standard testing for high power equipment. So it's a very versatile new source.
Yeah. So it's not just a high voltage power supply?
Not at all. No, not at all. It's really a mixed AC and DC source, which is very fast with quite a high bandwidth. So it can cover really a lot of different applications.
How does it work? I mean, do people come to you and say, I have the specific use case, or do people come and say, well, I need a high voltage power supply, or is it everything in between?
It's everything in between. So there are customers like the car manufacturers. They're more looking for a high voltage DC source for the component test. But there are also the test houses, and they are looking more for a source that can be used for different applications. Because for them, it's a matter of investing in a good source, and they can then basically get back the investment by selling the test hours. So the power wave is a really perfect fit for test houses where they need to cover different applications, not only electric vehicle testing.
Okay. And but this is not something you would use for testing flickering harmonics.
You would, yeah, exactly. So the power wave is a very clean source that can be used as a supply during harmonics and flicker testing, where we have the other equipment as well, so the analyzer, flickering, impedance, etc.
Okay. So we have the source, this amazing battery simulator with communications back and forth to the vehicle, back and forth to the charger, also back and forth to the charger.
Yeah.
What about? So how does this work with the Ripple NX? That's a product that's depending on when this video comes out, it's either coming soon or it's already out. But so how does this work with the Ripple NX?
So the Ripple NX is really used only for high voltage component testing. So it's not for full vehicle testing. And namely there, the components you test is motor inverters, the batteries, the high voltage batteries, but also the auxiliary equipment like the onboard charger, DC-DC converter, other like auxiliary equipment. So the Ripple NX, so the high power Ripple generator, the main focus is really on high voltage component testing.
Okay. I mean, it's also a different. I mean, we've had for example the AMP 200N and things like that. I mean, it's a similar concept, but on a much bigger dimension. And correct me if I'm wrong, but also much more tightly integrated to the software and the whole solution.
Exactly.
Can you talk about that a little bit?
Yeah, so the Ripple NX is basically the big brother of our small power Ripple generator. Because you have the low power Ripple generator, the AMP 200N was mostly used on small power components like electrical components on low voltage components on a car. But now we need to generate Ripple or superimpose Ripple on the high power devices on the car. So as I said, the battery and the motor inverters, and that's a whole new world to us. So you need like 10 or 20 times more Ripple power than until now we could deliver.
Oh, okay. What are we talking about for power? First of all,
So the power wave is at the 250 kVA, 250 kilowatt. It can supply up to 1500 volt and 500 amps DC.
Wow.
And the Ripple NX is twofold. So one is the EUT DC side. So there we can deliver couplers up to 1000 amps, 1000 volt. And the Ripple power between 5 and 10 kVA of Ripple power.
Wow, that's crazy. And the application really demands that.
Yeah, absolutely. So we developed it together with Daimler in Germany, and they absolutely need that Ripple power.
Crazy. That's a lot of power.
Mm.
So what other kind of insight can you give into the system, the power wave and the Ripple NX? I mean, you can give other kind of tips. I mean, so I know I've seen, for example, Ripple, and sometimes the Ripple starts like quite low frequency. Mm-hmm. Do we do it all with the Ripple NX, or how does that work, or is it proprietary?
No, it's not proprietary. I think, there are still several ways how you superimpose Ripple on DC lines. There are several, we call it coupling methods, and each of the methods has some like advantages and disadvantages. So we use the transformer coupling method, which is a very power effective way and very robust way of coupling. But the disadvantage is that it only works like above 300 hertz to above roughly 300 kilohertz.
Right.
But actually the Ripple test starts at 10 hertz, so
Okay.
there's a gap. And this gap we actually can fill with the power wave or the net wave. So the power wave for the lower frequency can generate the DC supply plus the Ripple on top of it.
Okay.
Yeah, so we close that gap in like kind of a system approach.
And over a certain frequency, then the Ripple NX jumps in.
Yeah, exactly.
Okay, and that's all. I mean, is it transparent to the user? Or did he just put it in software? I want to sweep, or how does it work from?
It's all done by our software. So if it's a power net wave plus the Ripple NX, the user wouldn't notice when it switches from one to the other. Yeah.
Wow. Okay. Because some of the standards, the way they're written, it seems impossible. Yeah. Put a 3 hertz, as an example. Put a low frequency sine wave over a transformer couple, or just figure it out somehow.
I mean, we can't bend the physics, right? So
Right. But we figured it out.
Yeah, we found a solution to basically cover everything that the standard requires.
Okay. That's amazing. I mean, just summarize what Thomas just told us. So basically, we have a device that simulates the charger, can test the charger both on the input, on the high, on the voltage side, and as a load, right?
Yeah.
And simulate the battery in the actual application.
The electric vehicle component tests, yes.
Well, that's. I mean, I'm proud of that. I mean, that's like
Yeah,
that's a big.
right.
Well, you just,
Product, yeah.
honestly, you're just the first one today. You have to be proud of it.
Exactly.
All right, everybody. Thanks for coming along for this very exciting launch presentation with Thomas. Thomas just finished packing the first one today, and thanks. I hope you found this interesting. If you like it, please put a comment down below. If you have any questions, maybe something we missed, something we'd like to talk about, that we'd like to talk about more, or you'd like to know more about. Otherwise, I'd like to say, Thomas, congratulations on the launch, and thanks for coming.
Yeah, thanks for having me.
And thanks everybody for watching.
Thanks.